Hi everyone, good day. This is Dr. Vaughn, and for this week, we will be discussing about your phosphate, other electrolytes, and your anion gap. So this will be our last lecture for our electrolytes and also my last lecture topic for the laboratory portion. So for your phosphate and other electrolytes, basically your lactate, and lastly, we will be discussing about the importance of your anion gap. For this week, our learning objective is to know the different functions of each of these electrolytes, your phosphate, lactate, and know the clinical importance or significance to understand why we need to measure each. Then, to know the different specimen considerations, identify the different methods to be used for its determination, and lastly, we have to determine the normal range of these electrolytes. So first, we will be discussing about your phosphate. I know that you are already familiar with the phosphate. The control, remember your calcium homeostasis. Remember that it also, your hormones that controls your calcium is also the same hormone that will regulate your phosphate. So we will see later on. So it said that your phosphate is found everywhere in your living cells. Remember that the genetic materials, your deoxyribonucleic acid and your ribonucleic acids are complex phosphodiesters, meaning they are also composed of your phosphate group. So your phosphate participate in many of the most important biochemical processes because remember, in your glycolysis, in your citric acid, phosphate is involved in the transfer of your energy. And lastly, it is also inversely related to calcium. So as what I said, remember your calcium homeostasis? The same hormones that are going to regulate your phosphate. So we'll see that later. Here, your phosphate is said to be the reservoirs of your biochemical energy. So including your ATP, creatine phosphate, and your phosphoenol pyruvate. So all of these substances is composed of your phosphate. And also your red blood cells. Your red blood cells has this 2,3-BPG or your 2,3-BPG, which is your biphosphoglycerate. So again, in hematology, what is the action of your 2,3-BPG in your red blood cells? The alterations in the concentration of your 2,3-BPG in your red blood cells affects the affinity of your hemoglobin for oxygen. So, in short, pagtaasan natin ang levels ng ating 2,3-BPG, anong mangyayari? With an increase facilitating the release of your oxygen in tissue and a decrease making oxygen bound for hemoglobin. Pag mataas, nare-release ang oxygen. Pag mababa ang levels ng 2,3-BPG, nagiging ang oxygen nagbabind sa ating hemoglobin. So that's the function of your 2,3-BPG. So remember that your phosphate is involved in a different biochemical processes. It participates in many of the most important biochemical processes, and it's also a reservoir of your biochemical energy. So remember, glycolysis is one of the processes, biochemical processes, that is used by our body to generate energy. And remember, phosphate is a reservoir of your biochemical energy. That is why phosphate is involved in your glycolysis. So biochemistry, I know seeing this diagram, you really don't like this kind of diagram. I guess same to you guys. I can still remember during my board exam sa biochemistry. So biochemistry is the first subject during our PLE. And since biochemistry, anything about chemistry, I really don't like chemistry. Swear, so napaka-ironic na I am teaching clinical chemistry. So I don't like biochemistry, and since hindi ko siya, kasi nahihirapan ako kasi you have to memorize everything. It's not a matter of just familiarization. In order for you to familiarize everything, diba, you have to memorize. Kasi nga, hindi mo naman ito mapafamiliarize if you're not going to memorize all of these steps. So, sobrang daming step na kailangan i-memorize, the action of the enzyme and all, anong mga energy na kailangan, and so the like, and pati mga disorder. For example, kulang ka na dito ng enzyme, may mga certain disorder na. So, biochemistry is my least favorite subject ever since medtech time. Kasi nga, napakahirap. Ang daming i-memorize and I don't like memorization. Mas gusto ko yung mga kailangan lang tandaan, i-familiarize, and as long as you know the processes, it's easier for you to grasp the idea. I don't like really memorization. So during my PLE exam for biochemistry, since first subject ang biochemistry, so in short, dapat kong pagandaan. Kasi nga, if mababa na ang grades ko, if bad mood na ako sa biochemistry, so for the rest of the exam, in short, mababa na rin ako, mababad mood na ako. So, wala na akong gana mag-answer ng exam. So, biochemistry, pinag-aralan ko siya double time since ayoko siya, since nahihirapan ako sa biochem. So, double time. Kailangan ko mag-double time, aralin lahat, yung sa lahat, yung during the review talagang focus ako. Pero, during the board exam, since first subject siya guys, so pray lang dito kay Lord. Lord, please, kahit sa number 1 lang. Kasi the number 1 will determine what will be your fate all along the test. So, kahit sa first question pa lang, Lord, sapat sa first question. Dapat matama na ako ang first question para at least sa mga next following question, at least na ako'y confidence na mo answer. Kaya tama ako sa number 1, sure ko sa number 1. So, when I read the first question, blah, 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 blah. Oh my God. Parang hindi ata ito na-discuss sa review. Parang hindi ko din nabasa to. Parang wala dito sa med school. Sige lang, Lord. Skip ko lang muna. Baka sa number 2 makakasagot na ako. So, I tried to read an hour. So, skip ko muna ang number 1. So, nag-number 2 ko muna. Number 2, blah, 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 blah. Shit, related lang siya sa number 1. So, correlated ang question niya. Para siyang case analysis na connected sa number 1. Still, I still do not know this. Sige lang, baka sa number 3, matama ako. So, skip ko sa next, blah, blah, blah. So, nagbasa ko number 3, blah, 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 blah. And still, in number 3, I still do not understand and do not know the question. It was really difficult. So, anong ginawa ko? From number 3, bumalik ako number 1, sinagutan ko na lahat. Hindi na ako nag-skip. And I just tried my best to answer. Parang confidence na lang. Parang ito. Parang wala pa akong letter B tapos maganda ang letter B. B na naman ako. Ay, it's really difficult. And parang confidence na lang yung nagdala ato. And ang way of thinking ko, pag mahirap ang question, ginaisip ko na lang na pag hindi ko to alam, most probably hindi din to alam na makatabi ko. Majority of them parang siguro for sure hindi din to nila alam kasi hindi tinuro to sa review center. Almost all of us have the same review center, so pantay-pantay lang ang labanan kasi at the end of the day, no matter how, kung lahat kayo nahirapan, it's still based on the MPL. So at least pantay-pantay lahat. So it's better na mahirap ang exam kasi nga pantay-pantay na nahihirapan ang lahat. So at the end of the exam, when I asked my friends, it was really hard guys. As in like wala gitudlo sa med school, wala gitudlo sa review center. It's really different. Kaya nga sa board exam nyo, you will really encounter questions na you never heard, you never learned at all. So may experience you din yan soon. Kaya biochemistry is really one of my lowest subjects sa PLE exam. And also, pati man sa aking medtech time, clinical chemistry was also my lowest subject. Very ironic nga, clinical chem ang aking tinuturo. Very ironic kung ano pa mga subject na nahihirapan ako, ito pa yung ginaturo ko. Parang napaka-ironic. So anyway, again, we'll just review I don't want you to memorize this. All I want you to know is that why is it your phosphate is involved in your glycolysis and other biochemical processes? Remember, your glycolysis has 2 important phases, right? We have your energy investment phase. Diba sa first step, meron tayong tinatawag na energy investment phase. Ang sa next part is we have energy generation phase. So, anong ibig sabihin yan, Doc? Diba sa first 3 steps ng ating glycolysis, yan yung investment phase. Ibig sabihin yan is uutang tayo ng energy. Uutang tayo ng phosphate sa ating ATP para mag-undergo ang processes. Kasi nga, if walang energy, then the process will not occur. Pero sa second phases dito, magkakaroon tayo ng energy generation phase. Dito na tayo nagkakaroon ng energy. Kaya nababayaran natin yung utang na ginamit natin during sa ating investment phase. Check natin Remember, your ATP has your phosphate, right? Glucose to glucose 6-phosphate. Ano ang first enzyme na gumagamit nito para to convert your glucose to glucose 6-phosphate? It's from the name itself, para transfer of phosphate group. It's your hexokinase. Automatically dapat yan. When you hear the word kinase, it's a transfer of phosphate group. Kaya, gumagamit ka ng ATP, then your ATP, since you used your phosphate, your ATP becomes ADP. From glucose, you add phosphate here from the ATP, nagiging glucose 6-phosphate. Next, anong nangyayari? Nagkakaroon ng isomerization, kaya nagiging fructose 6-phosphate isomerization. Basically, it's just the same. It's a matter of the rearrangement of your molecule. Parang mirror substance lang ito. Glucose 6-phosphate, fructose 6-phosphate. Then, what happens next? Your fructose 6-phosphate again will be converted into fructose 1,6-biphosphate. Anong enzyme ang ginagamit natin dito? It's still your kinase, but it is your phosphofructokinase. So, phosphofructokinase, it still uses your phosphate. And again, there is a word kinase, meaning it is the use of your phosphate to transfer your phosphate. So, ATP, nagiging ADP. So, in short, your fructose 6-phosphate, nag-add ka ng another phosphate group, kaya nagiging fructose 1,6-biphosphate. So, in short, sa first step is just a energy investment. Ilang ATP ating nagamit dito? 2. Pang-convert ng glucose to glucose 6-phosphate to become from your enzyme hexokinase, isang ATP. For fructose 6-phosphate to convert into fructose 1,6-biphosphate, kailangan tayo ng another energy. So, your ATP. So, in short, a total of 2 ATP. Pero your glucose here will be converted into 3 molecule, your 3-glyceraldehyde. Remember that your glucose is 6 molecule. Iko-convert siya into 3 molecules. In short, 2 substance ang na-form. Kaya ito, 2 3-glyceraldehyde P. Sa process na ito na yung proseso na kung saan nagkakaroon na tayo ng ATP generation. Dito, nakikita nyo, there will be ATP formation and another ATP formation. 2 dito kasi nga 2 substance. 2 din dito kasi nga 2 substance. Kaya a total of 2 pyruvate. So dito sa energy generation, nagkakaroon tayo ng 4 ATP. But remember, in your investment, may utang tayo ng 2 ATP. So in glycolysis, we have a total of 2 ATP. So guys, this process is I just want to show you that in glycolysis is that we need your ATP for us to generate more ATP. So in short, your phosphate is essential in the step. So that's why your phosphate is essential in different biochemical processes. So ayun, yan yung gusto kong ipakita sa inyo, that your phosphate is involved in the different biochemical processes. Again, don't have to memorize this, hindi naman to biochemistry. Alam ko ayaw nyo naman din to i-memorize. Of course, hindi na to kailangan na. It's okay. Next, your phosphate. So how do we regulate your phosphate? So regulation, phosphate may be absorbed in the intestine from different dietary sources. So still including your calcium. Remember your calcium, di ba? Pwede din siyang i-reabsorb sa ating intestine. So kasama ng ating phosphate. So released from cells into the blood and lost from bone. So in healthy individuals, all of these processes are relatively constant and easily regulated by renal excretion or reabsorption of your phosphate. So your phosphate could just easily be reabsorbed from the kidneys or can be excreted also from your kidneys. That's also one way of regulating your phosphate. So these are the different hormones or conditions affecting your phosphate level. Again, remember your vitamin D, your calcitonin, your parathyroid hormone, that is one involved in your calcium homeostasis. We already discussed what will happen to your phosphate level. But Doc, how about your growth hormone? Check natin. Again, for the regulation of your phosphates, your vitamin D acts to increase the phosphate into the blood. So increases both phosphate absorption in the intestine and phosphate reabsorption in your kidney. How about po yung growth hormone, Doc? So your growth hormone, increased secretion or administration of this hormone, specifically your growth hormone, phosphate concentrations in the blood may increase because of decreased renal excretion of your phosphate. So your phosphate has 3 important forms. We have your free, complex with ions, and protein bound, but majority are actually in free form. So in terms of the distribution of your phosphate, so your total phosphorus is approximately about 12 milligrams per deciliter or 3 to 4 milligram deciliter inorganic phosphate. So predominantly intracellular anion ang ating phosphate. So 80% of your phosphate is actually found in your bone, 20% in your soft tissues, and less than 1% only which is active in your serum or your plasma. So tingnan natin dito. This is your phosphate and your organic anions. Kita natin dito sa diagram that your phosphate is a predominant intracellular ion. Kita mo, intracellular ion. And a small portion lamang is only an extracellular, approximately 1%. So in terms of a clinical application of your phosphate, mayroon tayong tinatawag na hypophosphatemia when there is already a decreased serum level of your phosphate. So hypophosphatemia can be can be caused by increased renal excretion as well as with your hyperparathyroidism. Kasi nga, remember, increased renal excretion. Remember, your kidneys can excrete your phosphate, diba? It's one of the regulation mechanism of your phosphate. So in short, pagtaasan natin ang renal excretion, bababa ang phosphate level sa ating dugo. Kaya nagkakaroon ng hypophosphatemia. Decreased intestinal absorption as well as vitamin D deficiency or antacid use. Because of decreased absorption, walang intestinal absorption ng phosphate, in short, mababa din ang level ng phosphate sa ating dugo. Also, your antacid can inhibit the absorption of your phosphate patungo sa circulation because of your antacid. So these are the different disorders that will lead into hypophosphatemia. Hypophosphatemia occurs in about 1 to 5% of hospitalized patients. So these are just merely different disorders, but I want you to remember bakit sa alcoholism nagkakaroon tayo ng hypophosphatemia. Hypophosphatemia or alcohol abuse is the most common cause of severe hypophosphatemia. So Doc, bakit po tayo nagkakaroon ng severe hypophosphatemia because of your alcoholism? It's because probably as a result of poor food intake. Remember that your phosphate comes from your diet. Again, could also be due to vomiting. So when we vomit, then of course we excrete a lot of your phosphate. Kaya bumababa ang level ng ating phosphate. And nagkakaroon din tayo ng marked phosphaturia, meaning increased excretion of your phosphate. So these are the reason why nagkakaroon tayo ng hypophosphatemia sa ating alcoholism. So another conditions, hyperphosphatemia with acute or chronic renal failure. So in short, pag mayroon tayong renal or chronic renal failure sa ating kidney, anong nangyayari? Nagkakaroon ng hyperphosphatemia. Remember that your kidneys is involved in the excretion of too much phosphate. Pag nasira ang ating kidney, anong nangyayari? Hindi natin napapalabas ang ating phosphate. Kaya nagkakaroon tayo ng hyperphosphatemia. Also, increased intake, increased diet, so absorption in our intestine. We have also increased release of your cellular phosphate because remember that your phosphate is intracellularly, majority of your phosphate is intracellularly located. So, increased breakdown of cells will cause severe infection. Caused by severe infection, intensive exercise, neoplasm, and intravascular hemolysis. So, you may also have high levels of your phosphate from prolonged exercise. Bakit kaya nagkakaroon ng hyperphosphatemia during intensive exercise or prolonged exercise? Because it can lead to muscle damage. So remember that certain athletes and distant runners may have this kind of condition, your rhabdomyolysis. So lysis of your muscle cells. Remember, and these muscle cells may contain increased level of your phosphate. Thus, this can lead to hyperphosphatemia. Sorry for that. So again, what are the specimen that we use to determine inorganic phosphate? We have your serum, we have your lithium heparin plasma, your oxalate, your citrate, or your EDTA can interfere with the analysis. So in short, ang kailangan natin gamitin is your lithium heparin plasma. Then, hemolysis should be avoided. Kaya bakit? Kasi nga, your phosphate majority is intracellularly located. Circulating phosphate levels are subject to circadian rhythm. So, highest in late morning and lowest in the evening. So, also, we can also detect your phosphate using your 24-hour urine. So, determination of your inorganic phosphate, we have this method which involve the formation of an ammonium phosphomolybdate complex, which is measured by your UV at 340 nanometer or can be reduced to molybdenum blue, which is read between this wavelength, 600 and 700 nanometers. So what do you call this test or method? This is actually your Fisk-Subarow method. Your Fisk-Subarow method, which is a colorimetric method for determination of inorganic phosphate. So these are the different range of our inorganic phosphorus sa ating neonate, sa ating child, sa adult, and your sa urine. Remember, bakit kaya mataas sa ating urine? 13 to 42 because remember your kidney is essential for the excretion of your phosphate. Kaya makita natin na mas mataas sa level sa ating urine. Kaya nga, pag nagkakaroon tayo ng, chronic renal failure, anong mangyayari? Tumataas ang level ng ating phosphate kasi nga hindi siya na-excrete sa ating urine. That's why our kidney is very important in regulating your phosphate. So now let's proceed with your package insert for your phosphorus. So your phosphorus, using your photometric UV test for the determination of your phosphorus. So what is our method? This is the method. Phosphate reacts with molybdate in a strong acidic medium. So remember that, in a strong acidic medium to form a complex. So phosphate, i-react sa molybdate. So ito, kita natin sa reaction. Phosphate, nagre-react sa ating molybdate in a strong acidic medium. Anong ginagamit natin na medium, na strong acidic medium? It's your sulfuric acid, which is a pH of less than 1. So to form a complex, and this complex, the absorbance of this complex in the near UV is directly proportional to your phosphate concentration, which is now measured by your spectrometer. So the absorbance of this complex in the near UV is directly proportional to your phosphate concentration. So again, your phosphate group reacts with your molybdate in a strong medium, in your strong sulfuric acid or strong acidic medium, which is your sulfuric acid with a pH of 1. And then it will form now your complex. So this complex, which is directly proportional to the phosphate concentration. So anong laman ng ating package insert? Meron tayong reagent. Kasama dyan yung ammonium heptamolybdate, your sulfuric acid, your detergent, activators, and stabilizers, and we have your standard. So your reagent preparation, simple lang. You don't have to mix na. Meron tayong reagent, meron na tayong standard that are ready for use. So again, anong specimen ng kailangan natin? Your serum. Plasma must not be used. Anticoagulants may cause false low result, kaya hindi dapat gamitin ang plasma. Stability in serum, 7 days at certain degrees and 2 days with these certain degrees. So for our assay, anong wavelength natin? Ito ang ginagamit natin na wavelength, either 340 or 334 nanometer. So for the optical path, 1 cm, hindi na yan. Basta ang measurement, tingnan nyo, against reagent blank. 1 reagent blank per series is required. So meaning, sa isang batch ng phosphorus determination, kailangan it's against your reagent blank. For your pipetting scheme, pipette into cuvette. So ito yung reagent blank. You have to prepare your reagent blank. Again, ready na yung reagent blank natin. Then you have your sample and your standard. So your sample and standard, how many UL ang ating kailangan? 10 microliter. For the reagent, we need your 1,000 UL. So simple lang ang test na gagamitin natin. Mix, incubate at least 1 minute at room temperature. Then you measure the absorbance of the sample and the standard. So you have to check for the absorbance, separate sa sample and separate sa standard against your reagent blank within 60 minutes. So the calculation, basic lang ang calculation. If conventional unit for milligram per DL or for SI unit, millimoles per liter. Pag conventional, imumultiply mo lang sa 10. Yung absorbance ng ating sample, i-divide lang sa absorbance ng ating standard, imumultiply mo lang ng 10 to get the conventional unit. Pag gusto mo ng SI unit, anong kailangan natin? Pag SI unit, yung sample, i-divide sa standard, yung absorbance nila, imumultiply mo lang sa 3.2 to get the SI unit. So very basic. Next, the test is linear up to a phosphorus concentration of 20 mg or 6.4. Pag lumagpas ang iyong concentration calculation to 20 or 6.4, anong gagawin natin? You have to dilute the sample with higher concentration, 1:1 with your distilled water then you multiply the result by 2. So you just have to dilute that 1:1 and multiply the result by 2. Pag lumagpas ng 20 or 6.4 yung result na ating kinuha. Excuse me. So these are the normal reference range. So that's it. So you just read here. Technically, parang same almost electrolytes. Parang same lang na nakalagay na mga notes and quality control. So kindly just go over this. So that ends our phosphate group. Now let's proceed with our lactate. For the lactate, lactate is a byproduct of an emergency mechanism that produces a small amount of ATP or energy when oxygen delivery is severely diminished. Pyruvate is the normal end product of your glucose metabolism, glycolysis. So conversion to lactate is activated when a deficiency of oxygen leads to an accumulation of excess reduced nicotinamide adenine dinucleotide. Anong ibig sabihin nito, Doc? Pag nagkaroon tayo ng mababang level ng oxygen sa ating katawan, since our body needs a constant level of energy, syempre gagawa ng paraan ang ating katawan. Pag wala ng oxygen or diminished oxygen, tapos kailangan natin ng energy, anong nangyayari? Nag-undergo tayo ng anaerobic glycolysis kasi nga wala ng oxygen. So we have to undergo anaerobic glycolysis to produce energy. However, this anaerobic glycolysis will not produce a sufficient amount of energy. Kaya nagkakaroon tayo ng accumulation ng lactate to produce more ATPs kasi nga small amount of ATP lamang ang naproproduce ng ating lactate. So in short, nag-accumulate ang lactate because of that. Because we need constant energy. So makikita natin sa diagram na to. Remember yung aerobic metabolism, ganitong nangyayari, right? Yung aerobic metabolism, di ba? Your 1 mole of glucose, anong nangyayari? By the process of your glycolysis, ano nangyayari? Nagiging pyruvate. Then your pyruvate to undergo citric acid para makapasok siya sa mitochondria, kailangan ma-convert ang pyruvate into acetyl-CoA. Kasi si acetyl-CoA lamang ang makakapasok sa ating mitochondria. So your acetyl-CoA will undergo citric acid or your TCA. Your TCA now will help in the conversion of your NADH or your reduced nicotinamide adenine into oxidized nicotinamide adenine dinucleotide. In short, mag-undergo siya na oxidative phosphorylation in your mitochondria, rapidly oxidizes your reduced nicotinamide back to oxidized nicotinamide adenine dinucleotide because of the oxidative phosphorylation. Ano nga, again, medyo magulo. Diba? Your glucose. Remember, in the process of your glycolysis, ano nga nangyayari in the process of glycolysis? Ang end product ng glucose, nagiging pyruvate. Si pyruvate, i-convert to acetyl-CoA kasi nga kailangan ma-convert si pyruvate into acetyl-CoA because it will not be able to go inside your mitochondria. Si acetyl-CoA lang nakakapasok sa ating mitochondria. Kaya si pyruvate, which is the end product of your glycolysis, will be converted into acetyl-CoA. Your acetyl-CoA now will undergo the citric acid cycle. Doon sa TCA, mag-undergo din siya ng oxidative phosphorylation. Anong nangyayari sa ating oxidative phosphorylation? Yung oxidative phosphorylation sa ating mitochondria rapidly oxidizes. Remember, this is a reduced nicotinamide adenine dinucleotide. So, you have to oxidize this. Bakit nga? Pangalan niya, oxidative phosphorylation. Kaya ito ay tinatawag na aerobic metabolism. You need oxygen. So, oxidized phosphorylation in mitochondria rapidly oxidizes your reduced nicotinamide adenine dinucleotide into oxidized nicotinamide adenine dinucleotide. This formation will yield in the formation of your energy, and this is one way of generating sufficient amount of energy. So, nagkakaroon tayo ng a total of 38 moles of ATP produced. Unlike in your glycolysis lang dito, ilang ATPs lang ating na-produce? 4 ATP. Pero sa 4 ATP na yan, may dalawa pa tayong utang. So in short, ang napuproduce sa atin sa glycolysis ay 2 ATPs lamang. Pero when it undergoes oxidative phosphorylation, nagkakaroon tayo ng 38 moles of ATP because of the oxidation of your NADH into NAD+ through the process of oxidative phosphorylation. Ito yung importansya kung bakit kailangan ang oxygen kasi nga aerobic metabolism for us to generate sufficient amount of oxygen. Pero paano if mababa ang levels ng ating oxygen? Of course, pag mababa ang level ng ating oxygen, anong metabolism ang mangyayari? Of course, it's your anaerobic metabolism kasi nga wala tayong oxygen. Remember, one factor for the process to undergo oxidative phosphorylation, anong kailangan? Oxygen. Pag walang oxygen, nagkakaroon tayo ng anaerobic metabolism. So anong anaerobic metabolism? Anong nangyayari? Your glucose will be, remember, in the glycolysis process, anong ang end product ng ating glucose? It becomes your pyruvate. Pero pag walang oxygen, anong nangyayari? It will not undergo formation of acetyl-CoA. In short, hindi siya makakapasok sa ating tricyclic acid na cycle, your TCA or Krebs cycle. Hindi siya mag-undergo ng Krebs cycle. Therefore, hindi rin magkakaroon ng oxidative phosphorylation kasi nga walang oxygen. So, without oxidative phosphorylation, your reduced nicotinamide adenine dinucleotide accumulates, which favors the conversion of pyruvate to lactate. So, anong nangyayari? Nag-a-accumulate ang ating NADH or your reduced nicotinamide adenine kasi nga hindi siya mag-undergo sa Krebs cycle and oxidative phosphorylation. In short, dadami ang NADH. Pag madami ang NADH, it will favor the conversion of your pyruvate to lactate. So your pyruvate will now be converted into lactate. And this will cause you a formation of only 2 moles of ATP. So, sobrang mababang ATP lang ang kailangan ng ating katawan. So, in short, pag nagkakaroon tayo ng anaerobic metabolism and for us to generate a lot of energy, we have to convert more pyruvate into lactate. Kaya nagkakaroon tayo ng lactic acidosis. Remember guys, there are 4 fates ng ating pyruvate. So, I just remember, mayroon akong mnemonics dito. I can still remember it, your luwae. So, your pyruvate, luwae talaga. Your pyruvate will undergo 4 fates. First fate niya, your fate, F-A-T-E, your first fate, pwede siyang L, pwede siyang mag-undergo into lactate. Ito yung sinasabi natin, pyruvate to lactate. Pag nag-accumulate ang NADH, it will go to form into lactate. Next fate niya, magiging oxalo, pwede siyang maging oxaloacetate. Yung oxaloacetate, it will be a substrate for your gluconeogenesis. What else? Low-Y. A, magiging acetyl-CoA para mag-undergo ng Krebs cycle for your oxidative phosphorylation. And lastly, ethanol for the formation. So, that's the basic 4 fates of your pyruvate. Pero pag walang oxygen na nangyayari, anong nangyayari? Nag-a-accumulate ang NADH. In short, mag-favor ang formation ng pyruvate into lactate. So, excess lactate in the blood is an early or sensitive and quantitative indicator of the severity of oxygen deprivation. So, this is a very good indicator na nagkakaroon na ng oxygen deprivation sa ating katawan. So, how do we regulate our lactate? So, lactate is a byproduct of anaerobic metabolism. So, remember, it is just a byproduct. So, it is not specifically regulated. As oxygen delivery decreases below critical level, blood lactate concentrations rise rapidly and indicate tissue hypoxia earlier than your pH. Liver is the major organ for removing lactate by converting lactate back to glucose by your gluconeogenesis. Remember your gluconeogenesis, it's a formation of your energy from a non-carbohydrate source. So again, let's review what we discussed. Your lactate, remember, pag mababa ang oxygen sa ating katawan, anong nangyayari? Oxidative metabolism rate diminishes. So, mababa ang oxidative metabolism, meaning it will not undergo oxidative phosphorylation. Pag hindi ito mag-undergo ng oxidative phosphorylation, anong nangyayari? Nag-a-accumulate ang reduced adenine dinucleotide. So in short, pag mataas ang NADH, your pyruvate converts to lactate instead of acetyl-CoA. In short, fini-favor niya ang formation ng pyruvate into lactate. Pag ganyan ang nangyayari, nagkakaroon tayo ng lactic acidosis. So in short, much less ATP is produced because remember, ilang energy lang ang napuproduce sa ating anaerobic metabolism. It's only 2 ATP. Unlike in a oxidative phosphorylation, you have able to produce, ilang ngayon? 28 moles or 38 moles of your ATP. Next, much less ATP is produced. So ano nangyayari? Intracellular ionic environment disrupted. So in short, pag mababa ang ATP, wala ka nang napuproduce na energy, nagkakaroon na ng disruption ng ating intracellular ionic environment. Tumataas ang calcium, tumataas ang sodium, bumababa ang potassium, and bumababa ang magnesium. If your intracellular ionic environment is disrupted or unstable, this will lead to cell death. So in short, this is the explanation why decreased level of oxygen will lead to your cell death. This is the metabolic effects of hypoxia leading to cell death. So I hope na if you're being asked kung paano ang pathophysiology, kung bakit namamatay ang cell kung mababa ang oxygen, so this actually explain everything. So in terms of the clinical application of your lactates or your lactate for metabolic monitoring in critically ill patients for indicating the severity of your illness and for objectively determining patient prognosis. So sa lactic acidosis, meron tayong two types of lactic acidosis. Type A lactic acidosis is due to tissue hypoxia kasi nga magfi-favor ang formation ng pyruvate into lactate. So these are the possible causes. Meron din tayong tinatawag na lactic acidosis, no tissue hypoxia. Excuse me. One good example of that is your acute alcoholism. Kasi nga sa acute alcoholism, there will be formation of reduced nicotinamide adenine dinucleotide. So, mas maraming na-produce na reduced na nicotinamide adenine dinucleotide. Pag maraming reduced nicotinamide adenine dinucleotide, anong nangyayari? Nagfi-favor into the formation of lactic. So, kaya nagkakaroon tayo ng lactic acidosis. And also, remember your diabetes mellitus, nagkakaroon tayo ng diabetic ketoacidosis. So, in terms of determination of your lactate, specimen handling, so tourniquet should not be used. Kasi bakit kaya? Why do you think that we should not use your tourniquet? Because there could be venous stasis, and because of this venous stasis, it will cause an increase of your lactic levels. After sample collection, anaerobic glycolysis will occur. Heparinized plasma, but must be delivered on ice and the plasma must be separated quickly. So fluoride and your iodoacetate inhibits glycolysis, but specific method directions must be consulted. So again, for determination of lactate, meron tayong tinatawag na enzymatic methods. Enzymatic method for our lactic determination, we use your lactic oxidase and your peroxidase. Ano nangyayari? Uses lactic oxidase to produce pyruvate and hydrogen peroxide. Tingnan nyo, your lactate, by the action of your lactic oxidase, nagpo-form tayo ng pyruvate and your hydrogen peroxide. Your hydrogen peroxide, with the addition of your chromogen, by the action of your peroxidase, it will form a colored complex, and this colored complex will now be detected by your machine. So these are the different reference ranges for your lactate, for your venous. Iba-iba yan sa venous, arterial, and including your CSF. So that ends our lactate discussion. If you have any questions, please do not hesitate to ask me. Now let's go on with our last part of our discussion. We have your anion gap. So, Doc, ano po ba yung anion gap? So, yung anion gap is a very useful tool for us useful in indicating an increase in one or more of your unmeasured anions in the serum. It's also essential for quality control of your analyzer used to measure your electrolytes. So your anion gap is basically the concentration difference between commonly measured cations. So commonly measured cations, ano yung commonly measured cations natin? We have your sodium and your potassium, and also your commonly measured anions, we have your chloride and your bicarbonate. So there are only two commonly used methods for calculating your anion gap. So, this one or this one, depending kung anong given or makikita natin. If given ang potassium, so we use this formula. So, for your anion gap, it's either sodium plus potassium or without potassium minus your chloride plus your bicarbonate. So, your normal range for your anion gap is between 10 to 20 millimoles per liter. So ito, you can see this in your bishop. So this is just a demonstration sa ating formula of your anion gap from concentrations of anions and cations in normal state and in lactic acidosis. For example, pag normal nga, anion gap, diba, normal range ng ating anion gap is between 10 to 20. So this is normal. Paano ito na-compute? Remember your sodium. Sodium is 142. 142 plus 4. Ano yung 4? Potassium. So, sodium plus potassium. 142 plus 4. Isasubtract mo yan sa ating chloride plus your 28. Your 28 here is your bicarbonate. So, chloride plus bicarbonate, 103 plus 28. You add, then you subtract, then you get the value of 15. How about if nagkakaroon tayo ng lactic acidosis? So, if ano nga nangyayari pag nagkakaroon ng lactic acidosis, nagkakaroon ng derangement ng ating environment sa ating cell. It's either tumataas ang sodium, tumataas ang calcium, mababa ang chloride, tumataas ang bicarbonate, etc. etc. So it depends. Kaya nga nakita natin dito, yung sodium nagiging 141, your potassium nagiging 5. Then your chloride nagiging 103 and your bicarbonate nagiging 22. If you calculate this one, you get an ion gap of 21. So in short, this is high. In short, this is a high anion gap lactic acidosis. So basically, this is just a demonstration of how we compute your anion gap. So very simple. So of course, this will come out in your exam. So very simple lang man. Everything will be given. So there are a lot of reason why nagkakaroon tayo ng elevated anion gap. So ito yung mga different sources ng elevated anion gap. Dito acidosis kasi nga lactic acidosis. Nakita natin sa example, pag may lactic acidosis, nagkakaroon tayo ng mataas na anion gap. Actually guys, one essential gamit or tool ng ating anion gap is to differentiate what type of metabolic acidosis. Meron kasi kaming tinatawag na hagma and nagma. Ano yung nagma and hagma, Dok? Yung nagma, normal anion gap metabolic acidosis. Ang hagma, high anion gap metabolic acidosis. By the help of an ion gap, we will be able to narrow down our differential diagnosis. Kasi nga, nasa-separate yan. Meron kaming mnemonics na ginagamit for us to determine whether it is a normal anion gap or high anion gap na metabolic acidosis to differentiate what type of metabolic acidosis. So, actually, this will be discussed in medicine too. I just want you to show this so that you will be able to familiarize with this. Isang useful tool ng anion gap is to differentiate your metabolic acidosis. Paano ma-differentiate, Doc? It's either high anion gap metabolic acidosis or normal anion gap metabolic acidosis. Yun tinatawag namin na hagma and ito yung tinatawag namin na nagma. Pag makompute namin normal anion gap, this is the possible diagnosis. Pero na-compute namin na merong metabolic acidosis ang pasyente tapos mataas pa ang kanyang anion gap, these are the possible diagnosis. So ito yung mnemonics namin sa hagma, high anion gap metabolic acidosis, MADPILE. So methanol, uremia, diabetic ketoacidosis, etc., etc., etc. So, MADPILE. So, tingnan nyo, elevated. So, high anion gap. These are all your MADPILEs nga mnemonics. So, di ba? It's easier for you to memorize. So, elevated anion gap. These are the possible causes. MADPILE. So, same lang yan, guys. Dito nakalagay, uremia, renal failure, ketoacidosis, methanol, ethanol. Same lang yan dito. Mnemonics natin, methanol, uremia, diabetic ketoacidosis, infection, iron. So you don't have to memorize this. I know it's gonna be a lot. So you don't have to memorize this. I just want to show na yung anion gap natin is essential for us to determine what type of metabolic acidosis. Is it a high anion or a normal anion gap? Kasi nga, with that alone, kung alam namin na may metabolic acidosis ang pasyente, kinocompute na lang namin yung anion gap para to determine or to narrow down our possible diagnosis. So you don't have to memorize this. I just want to show this one. At least you are familiar with this one. You will encounter this in your med school. Again, remember your mnemonics. Just remember the mnemonics. Mud piles and hard up. So, anion gap, meron tayong tinatawag na decreased level of your anion gap. However, it is rare, unlike to a normal and high, di ba? Mas maraming mga differential diagnosis pag normal or high anion gap. Pero ang low anion gap, it's very rare. Hindi tayo masyadong nakakita niyan. Maybe only seen with hypoalbuminemia, decrease in unmeasured anions, or if there is your severe hypercalcemia or increase in unmeasured cations. So, guys, that ends our discussion. So, grabe, ang bilis lang ng semester. I'm already done with my lecture video. Parang, wow, ang bilis lang talaga. So, guys, with all my heart, thank you everyone for a fun learning discussion for the entire semester, and I hope that I was able to impart something in your journey as a medtech student. And I hope na you had fun with my discussion, and hopefully we will still see each other. So, lahat ng sinabi ko ng mga life lessons sa lecture na part, I hope na ma-apply nyo man din sa inyong life. Guys, thank you for everyone. If you need help, guys, I am just chat away, no matter, even if you're not my student anymore, I am more than willing to entertain you guys, swear. So, God bless you, good luck. See you on the other side. I'll always pray for you all, for all of your success, guys. See you soon as my future colleague, as medtechs and as physician. God bless you, everyone, and good luck.